This is the fourth video on absolute extrema, and we're continuing example 155. So we have our function that was given, we have our region that was given. In the first part of this, so in video 3, we found the critical points and we tested those. One critical point was 0, 0, and the other was radical 2 divided by 2 and radical 2 divided by 2. And we tested those. Now we'll test the boundary points. We have two kinds of boundary points. We have the ones along this line here, the x-axis, and then we have the ones on the circle itself. And so we have, for the first kind, x ranges between -1 and 1, y is equal to 0, f of x0 is equal to 0. For the second kind, x ranges between -1 and 1, and y is the square root of the quantity 1 minus x squared. That is the equation of the top half of the unit circle. So we'll testing this boundary is going to be a little intensive algebraically. So let's look at what happens with an fx radical 1 minus x squared. We substitute these into f, and this is our result. So what we're going to do is now we're going to look at a real valued function g, which is just this function because we've reduced this to a function of one variable. So we'll just call g this function, and we're going to find the max and min of g on the interval -1 to 1. So this now becomes a Calc 1 problem. We calculate the derivative, then we solve the derivative equal to 0. There is a lot of intense algebra here. I will go through this with you in class if you want me to, but essentially what happens is you get a common denominator here, you reduce this, you set this equal to 0, and then what you'll do is you'll play with that. You'll put something with a radical on one side of the equal sign, and then you'll square both sides. So you're just going to be solving a radical equation is what you're doing. But there's a lot of simplifying to it. It comes down to the point where you get, sort of like in the previous video, where we get a square equal to 0. We got a square less than or equal to 0. Here you're going to get a square equal to 0, which means the term that you're squaring is equal to 0. When you solve that, you're going to get two solutions. X is plus or minus the square root of 2 over 2. So we'll test. Now we have a real valued function on a closed interval. We found the critical points. We'll test those, and then we'll test the endpoints. So g of negative square root of 2 over 2 is 3/4. G of square root of 2 over 2 is -1/4. G of -1 is 0. G of 1 is 0. So g of negative square root of 2 over 2 corresponds to f of negative square root of 2 over 2 square root of 2 over 2. Because remember, that point is along this curve. So if x is negative square root of 2 over 2, y is positive square root of 2 over 2. We are not allowing the y's to be negative. Had we taken the whole unit circle into consideration, then we would have had to have considered the point negative square root of 2 over 2, negative square root of 2 over 2. But we don't have to consider that because we're restricting our attention to the top half of the circle. And so f of this point is 3/4. This point we actually already found. This is also a critical point. So this is a critical point on the boundary. We've already tested this one. So f of square root of 2 over 2 square root of 2 over 2 is -1/4. So this is our min, this is our max.